Hey everyone, and welcome. Today, we are prying open the dentist's toolbox to really get a look at the science behind one of the most common things dentists do, fillings. We're going to cover everything, from the cements that build the foundation to the classic silver fillings and, of course, the modern tooth-colored ones. So let's dive right in. I mean, have you really ever wondered? You're sitting back in that chair, you hear the clinking of tools, and then they start mixing up these strange-looking pastes and putties. What is actually going into your tooth? Well, today, that's exactly what we're going to find out. You see, it turns out that a dentist's toolbox is packed with all kinds of different materials. It is absolutely not a one-size-fits-all deal. Each material has a super specific job to do, whether it's building a solid foundation or creating that final tough-as-nails restoration. Right, so before the main filling even goes in, dentists often have to lay down a protective base or a liner. The best way to think about it is like using a primer before you paint a wall. It preps the surface and, more importantly, it protects everything that's underneath. First up in our lineup of these foundational materials is Zinc-Oxide Eugenol cement. This stuff is one of the originals, a real classic in the dental world, and for a very good reason. It has some really unique, soothing properties that make it totally invaluable in certain situations. Okay, so the secret sauce here is the composition. A common brand, Kalzinol, is basically a zinc oxide powder mixed with a liquid called eugenol. And here's the cool part. Eugenol is the main ingredient in clove oil, which people have used for literally centuries to soothe toothaches. That's what gives this cement its calming, almost sedative effect on the tooth's nerve, making it just perfect for a temporary filling or as a protective liner deep down in a cavity. And get this doesn't come in a tube. The dental assistant actually mixes it up fresh, right there on the spot. They carefully fold the powder into the liquid on a cool glass slab, which helps control how fast it sets. The goal is to get this thick, putty-like consistency that can be packed right into the tooth. It's like a little chemistry experiment happening chairside. Next up, we've got another foundational material, but this one has a totally different mission. This is calcium hydroxide cement, and its main job is to act like a bodyguard for the most sensitive living part of your tooth, the pulp. Now, what's really fascinating here is that a material like Dycal actually comes as two separate pastes. You've got a base paste and a catalyst paste. When you mix them together, it kicks off a chemical reaction that makes the material harden, but its real superpower is what it does inside the tooth. When a cavity gets really deep and super close to the nerve, this stuff actually encourages the tooth to heal itself by building a new layer of dentin. That's the hard tissue right under the enamel. How cool is that? And unlike that last material we saw, mixing this stuff is crazy fast. You just squeeze out equal amounts of the two pastes, give them a quick 10-second stir, and bam, it's ready to be placed in the tooth to start its therapeutic work. All right, our third cement is a bit of a multitasker. Glass ionomer isn't just a liner. It's actually strong enough to be a filling all on its own. And it's got a pretty unique superpower that sets it apart. So let's look at what makes it so special. See that composition? Fluoroaluminosilicate glass. That fluoro part is the key. It means the material actually releases a tiny bit of fluoride over time, which helps fight off any future decay right around the edge of the filling. Plus, it chemically bonds directly to the tooth structure itself, which is a massive advantage. The whole application process is pretty unique too. After a quick mix, the dentist treats the tooth surface with a special liquid called a conditioner. This preps the tooth so that the material can form that strong chemical bond we talked about. Then the cement is packed in and firm pressure is applied to make sure it's sealed up tight. Okay, so we've laid the foundation. Now let's get to the main event, the filling materials themselves. And we have to start with the original, the classic workhorse of dentistry, amalgam. Amalgam, which most people just call a silver filling, is an incredibly strong and durable metal alloy. As you can see, it's a mix of metals like silver, copper, and tin. And the magic ingredient that binds it all together into a workable paste is liquid mercury. Now, once it sets, that mercury is completely locked into the alloy, creating a filling that is just exceptionally strong. This is why it's been the go-to material for your back teeth, your molars, for over 100 years. They can really take a beating. The mixing process, you'll be glad to know, is completely contained and automated. The alloy powder and the mercury come in these little pre-dosed capsules. The capsule gets popped into a special machine called an amalgamator, which just shakes it at a super high speed. That process is called trituration, and it guarantees a perfect, consistent mix every single time. Now, because amalgam does contain mercury, handling it requires some really strict safety protocols. This is absolutely critical. Dental professionals are highly trained to work in well-ventilated areas, they never touch the material with bare hands, and they have very specific procedures for collecting any leftover material to ensure the safety of both the patient and the entire clinical team.
But what if you want a filling that, well, doesn't look like a filling at all? That brings us to the modern aesthetic alternative to amalgam, composite resin.
Composite is basically a tooth-colored plastic resin. Its recipe includes a resin matrix, tiny filler particles for strength, and pigments that can be matched to the exact shade of your tooth. There's also an initiator in there, which plays a really crucial role in how this material hardens, as we're about to see. All this makes it perfect for fillings anywhere, but especially in the front of your mouth where you can see them.
And right here, this is the game changer. This is the single biggest difference in workflow compared to everything else we've looked at so far. There is zero mixing required. It comes completely ready to use right out of the box.
This just shows you what a completely different process it is. The composite comes in a small pre-dosed tip called a compule that gets loaded into a delivery gun. The dentist applies the material straight into the cavity, but they do it in small layers. Then they take a special blue light and use it to cure or harden each layer for about 40 seconds. This gives the dentist total control over shaping and setting the filling. But wait, the job isn't done just because the filling is in the tooth. This final step is absolutely crucial for how long the filling lasts and how comfortable it feels: finishing and polishing. And as you can see, the polishing process is totally tailored to the material. For amalgam, it's a multi-step process with different burrs and paste to create an ultra-smooth surface that resists corrosion. This helps it last longer and keeps plaque from sticking to it. For composite, on the other hand, they use specialized systems with really fine grit polishers to get a super high-gloss, natural-looking finish that not only blends in perfectly, but also feels completely smooth to your tongue. So from hand-mixed cements that soothe the tooth to high-tech, light-cured resins that disappear from view, we've taken a quick journey through the incredible evolution inside the dentist's toolbox. Every single one of these materials is a feat of chemistry and engineering, designed for a very specific job. It really makes you wonder, with all the new advancements in things like biocompatibility and digital dentistry, what new materials are waiting just around the corner, ready to redefine what the perfect filling even is?